Okay, let's get some factoring done. Here we're going to talk about factoring the difference of two squares. I always call this dots. D for difference, O for of, T for two, and S for squares. D-O-T-S. Remember, you can only factor dots. You can never factor sots. Okay, and I usually use this in class to help students remember that you can only factor the difference of two squares. Dots is a candy. I don't eat them. They stick to my teeth. I don't enjoy that. But dots is a candy. If there was a candy called sots, I don't know if I would like that because it reminds me of socks. So that's pretty gross. So again, that's the box to help you to remember that it's only the difference of two squares that can be factored, never the sum. Okay, so we are going to reverse those special products that we learned about in the polynomial section in chapter P, section 4, for the sum and difference of two terms. So dots is always going to factor as conjugates. So what you get when you factor is a plus b multiplied with a minus b. Okay, and again, on any type of assessment, I would have a formula sheet for you to help you, I guess, with the factoring. However, you have to understand what the formulas mean, because I don't tell you what they mean. I don't give you this part. I just give you this part. Okay? So when you see this, you should know this is how the difference of two squares factors. All right, so our first example, how do you do this? How do you factor dots? Well, we're simply going to take this and say, all right, well, this is going to turn out to be two binomials. And really, you know, I could think of this trinomial x squared as x squared plus 0x minus 49. Now it's a trinomial. So what two numbers multiply to 49 that when I subtract them give me a 0? Well, isn't that positive and negative 7? So when I factor this, I get x plus 7, subtract 7. And that is my answer. Now, if you didn't want to think of it in terms of a trinomial, then all you have to do to get this x and this 7 is take the square root of the x squared and take the square root of the 49. So the square root of x squared equals x, and the square root of 49 is 7. And this is my a and my b. Okay, this is my a value, and this is my b value. So it's a plus b times a minus b. So again, either write it as a trinomial, or think of it in terms of taking the square root. Now, if the leading coefficient is a 1, this works out pretty well. If the leading coefficient is bigger than 1, then you're going to have a trinomial where the a is bigger than 1, so it's a little bit more work to do. So really, square rooting for these guys that have a coefficient larger than 1 for your quadratic term really helps to do this, because here my a is square root of 25 is 5, square root of x squared is x. So that's my a value. Square root of 144 is 12. So this is going to factor as 5x plus 12 multiplied with 5x subtract 12. Okay, that's pretty basic factoring, the difference of two squares. You just have to recognize that these are squares. And sometimes there's a GCF in here that maybe this number would be like a 75 instead. Well, you'd have to take a 3 out to make it be a 25, as long as each term is divisible by 3. We might have some examples coming up, or especially in your factoring packet like that, where you first have to take a GCF out, and then you have to factor it more. Sometimes repeated factorization will occur, and so you're going to have to factor completely. Okay? Like this problem. Well, x to the fourth is a square. Remember, Any variable raised to an even power is a square. 625 is a square. 25 times itself is 625. So it would behoove you to know your squares. 1 squared, 2 squared, 3 squared, 4 squared, all the way up to 20, and then of course number 25. Those occur a lot in mathematics. So what do? I take the square root of x to the fourth. I take the square root of 625. Square root of x to the fourth is x squared. Square root of 625 is 25. So now I'm going to write my product of two binomials, x squared plus 25, x squared subtract 25. I'm not finished. This thing is not completely broken down. Folks, think of a factor tree. Like the number 12. 12 could be written as 3 times 4. But guess what? The 4 is not in its lowest factored form. I bring the 3 down, and I could bust apart the 4 into 2 times 2. This part here is not fully factored. I can't factor this. This is the sum of two squares. That's sots. You can never factor sots. This is the difference of two squares. This is dots. You've got to break this down. So to factor completely, I got to keep this. This is part of the answer. Just like I did up here on the factor tree, I had to keep the 3. Because 2 times 2 is 4 only. I still need the 3 in the bottom row to say this thing equals 12. So now I'm busting apart the x squared, subtract 25. Again, take the square root of x squared, you get x. Take the square root of 25, you get 5. One's plus, one's minus. Now I'm fully factored. And notice I do have a product of binomials, product of terms. So if you have questions, post it on the discussion or ask me a question in class. All right, side 2 of the note sheets. We're going to do pages 1, 2, 3, and 4. Factoring perfect square trinomials. Perfect square trinomials when the leader and what I call the ender are perfect squares. Now, sometimes a trinomial looks like it's a perfect square trinomial when in fact it's not. So be cognizant of that. Some of these are tricky. This is the reverse of squaring a binomial. Okay, the sign in the middle is the sign of the middle term. I'm going to take the square root of this, the square root of this. And I'm going to get one binomial that's exactly the same as the second one. This tells me it's the sign. Okay, so how is this going to factor? Well, it's going to factor as square root of A is A, square root of B is B, and the guy in the middle is plus. I'm going to get 2 exactly the same. Same thing here. Square root of A squared is A, square root of B squared is B. I'm going to get 2 exactly the same, hence my squaring on the outside, and my sign is minus. Now I will tell you, for the factoring packet, all, A plus B times A plus B must be written as A plus B quantity squared. Okay, please don't write this on your answer sheet because I'm going to take points off. I want you to write it as a single binomial squared. This is going to be important when we get into completing the square. Trust me, there's a method to my madness as to why I want you to practice doing this. Okay, it leads into something later. All right, factor the perfect square trinomials. I have to ask myself, is this a perfect square trinomial? Well, it's telling me it is, but it's not always going to tell you that it is. So I'm saying the square root of x squared is x. The square root of 100 is 10. So this is looking like x and 10. Sign in the middle should be plus, and I'm thinking it's that squared. I'm going to test it. How do I square a binomial? I square the first, I get x squared. I square the second, or the last guy here, I get 100. First times second is 10x, doubled is 20. So it works. I can't break this down any further. 1x to the first power and 10 have no common factors, so I'm done. Okay, so again, what did I do? I took the square root of x squared and got x. I took the square root of 100 and I got 10. And I knew that was my A and my B. The next one. Is this a perfect square trinomial? Well, test it. Square root of x squared is x. Square root of 64 is 8. I'm thinking I get 2 of these, and the sign in the middle is subtract. Square this, x squared. Square negative 8, positive 64. First times second, negative 8x. Doubled is negative 16. I'm golden. Last one. 36 is a square. The square root of that is 6x. 49 is a square. The square root of it is 7. Signs are the same, they're both plus. Or just pick up the sign in the middle. But the rule for the signs works here. 2 of those. Let's check it. 6x squared is 36x squared. 7 squared is 49. 7 times 6, 42, doubled, is 84 and is positive. So yes, I can be sure and confident that I have factored that correctly. Okay, the next kind of factoring is factoring the sum and difference of 2 cubes. Now, I would recommend that you use the formulas for this. Okay, so when I'm factoring a cubed plus b cubed, it's always a binomial multiplied with a trinomial. Always is a binomial multiplied with a trinomial. Always. And this trinomial can never be factored. Okay, if I would try to factor it by using something like completing the square, I would get an imaginary number. So just memorize that factoring cubes is always a binomial times a trinomial, and that trinomial can never be factored. It's prime. So how do we do this? Well, they're formulas. In a similar fashion, when this was a squared minus b squared, because remember we couldn't factor the sum of squares, only the difference of squares, never sots, only dots. With cubes, we could factor sum and difference. Think of it like cube roots. You know, you could take a cube root of a positive number or a cube root of a negative number. And so this is why the sum and difference of cubes can be factored. But with squares, remember, we couldn't take the square root of a negative number. We could only take a square root of a positive number. And so that's the only reason why, we can do dots but never sots. All right. But in a similar fashion, you just take the cube root of A and the cube root of B, and you get A and B. The sign in the middle here is the same. Then what do? Well, ask yourself, what do I multiply with A to get A cubed? It's got to be A squared. And what do I multiply with B to get B cubed? It has to be B squared. The middle is always just A times B. We're not doubling anything. This end is always plus, because whether B is positive or negative, when I square it, it goes positive anyway. Here's where your opposite sign comes into play. If this is plus, then that's minus. This is always plus on the end. Again, cube root. I get an A, I get a B, sign in the middle has to be minus. Over here, I need an A squared. On the end, I need a B squared. It's always plus on the end. It's always AB in the middle. If this is subtraction, then this is addition. You have to have opposite signs to make those middle terms go away. Notice, there's no middle terms here. Like this problem here, x cubed plus 27. There's no middle terms. I don't have an x squared, a quadratic term, and I don't have a linear term. So we need opposite signs somewhere to make these things sum to 0 when I expand this. Okay, so how are we going to do this? Well, this time we're taking the cube root, because x cubed is a cube and 27 is a cube. So the cube root of x cubed is x. The cube root of 27 is 3. So here's my a and my b. Okay, I'm going to set it up. My a is x, my sign is plus, my b is 3. Now I'm going to square the x and get x squared. I'm going to square the 3 and get 9. I'm just going to multiply them together. Remember, I'm not doubling. I'm not squaring a binomial. Okay? I'm factoring. Squaring a binomial is multiplication. This is factoring. So I just multiply 3x. This is always plus on the end, and that's where my minus has to be. This can never be factored. Two numbers that multiply to 9 that when I add them give me a 3. 3 times 3, when I add those I get 6. Not possible. 9 times 1 is 10, because I'm going to add. That's not that. This can never be factored. Okay, if you have questions, post it on the homework discussion. All right, 125 is a cube. X cubed is a cube. 343 is a cube. So this is going to come out as 5x. This is going to come out as 7. There's my a, and there's my b. So I got 5x. The sign is subtract. The b is 7. Now, you have to square. You need to square 5x, not just the x, okay? So be cognizant of that. And then we get 25x squared, and this is what goes up here, okay? So I have to square this. It's the a squared. The a is 5x. It's product. 25x squared. Square negative 7, you get positive 49. Multiply them together is 35x. If this is minus, this is plus, and I'm done. Okay, so not difficult if you know how to use the formula. All right, now we're going to pull this together, and I'm going to end the notes here. On the next video lesson, we're going to learn how to factor expressions with rational exponents. They're not polynomials, but we can still factor them, and that's a good skill for calculus. So, here's our strategy for factoring polynomials. You always first, in every problem, look for a GCF. Look for a GCF. If there is none, then go on. You may have only 2 terms. You may have 3 terms. You may have 4 or more terms. Okay? So again, you might only have a polynomial with 2 terms. Maybe the polynomial has 3 terms. Maybe you have 4 or more. There are special cases when there are 2 terms. It could be the difference of 2 squares. That's dots. That's always going to factor as a plus b times a minus b. It could be the sum of cubes, or the difference of cubes. Remember, if it's sum of cubes, this would be a plus b multiplied with a squared minus ab plus b squared. Difference of cubes is going to factor as a minus b multiplied with a squared plus ab plus b squared. Okay, those are the formulas, if you will. If there are 3 terms, it could be a perfect square trinomial. And remember, a perfect square trinomial is always going to factor into a single binomial squared. Okay, so your perfect square trinomials is always going to factor into a single binomial squared. So in other words, if you had a squared plus 2ab plus b squared, And that's going to equal A plus B quantity squared. And you have to write all your answers like this for your perfect square trinomials in your factoring packet. If it's not a perfect square trinomial, you have to go back to that trial and error and test combinations, okay? I think those are the fun ones. And then if you have 4 or more terms, this was our grouping. Remember, we grouped 2 together and then 2 together, and we looked for a GCF within each group. Sometimes, though, they're tricky. And I'm gonna show you one here on the example. Letter B down here at the bottom of the page, where you have to group a trinomial and a monomial. And then at the end, you got to make sure that the polynomial is factored completely. Remember my factor tree when I drew a factor tree for 12. You had to factor it down to its prime factors, right? So I'll do it again. 12 was 4 times 3. 4 is 2 times 2. But then I still need this 3 because it's 2 times 2 times 3. That's 12. All of these numbers down here in the bottom row are prime numbers. Okay, so these are the prime factors of 12. So we apply that same thing to polynomials. You have to factor it down all the way. All right, let's look at these 2 examples, and then we'll be done with this part of the video and the section. All right, so I look here, and I'm like, well, 3's not a cube. This is something, no, this isn't anything to deal with cubes. But, 3 divides 3, and 30, and 75. So I have a GCF here first. Okay, and the GCF is not just 3, but in fact all of these terms in this polynomial have an x. This got x to the first power, second power, and third power. The biggest thing I could take out of all of those is 1x, so x to the first power. Okay, so I'm going to write my GCF on the outside. And what do I have left? I've got x squared, subtract 10x, add 25. And then you have to ask yourself, can I factor this? This looks like a perfect square trinomial to me. That's an x squared, and that's a 25. You could test it. If it doesn't work, erase it and try something else. I'm thinking it's a perfect square trinomial. I'm going to put an x here. I'm going to put a 5 here. I'm thinking that it's this thing squared. Signs are the same. They're both negative, so the middle is minus. I'm going to test it. How do I square a binomial? Square the first. X squared is x squared. Square negative 5, that's 25. First time, second, then double does give me that. So I know this is my final answer. I have factored completely, and because all of my factors are prime, and so I'm not missing anything. Okay, again, I know some students are going to want to write this as x minus 5 times x minus 5, but you have to clean it up and write it as one binomial to the power of 2. Okay, the last one, a sort of challenge problem. You should notice something different about this polynomial with 4 terms. Here I have a quadratic variable x, and here I have another quadratic variable a. When that happens, when you have two distinct quadratic variables, this is an indication that you're going to group a monomial and a trinomial. Okay, and so the distinct factor, like this is an x squared and this is an x term and this is a constant. I'm going to rearrange this and I'm going to put those 3 in a grouping as a trinomial, and I'm going to move this negative 36a squared off by itself. So this is the one that's unlike the rest. I understand that 100 doesn't have an x on it, but if I'm grouping a trinomial and a monomial, it makes more sense for me to write this and group this as x squared plus 20 times x plus 100, and then subtract 36a squared. And you're going to see what happens, and this is another reason why I want you to do this, what I told you up here. If you've got two exactly the same, write it as a single binomial squared. This is a perfect squared trinomial, and I'm going to write it as a single binomial squared. This is x, this is plus, this is 10. X squaring this gives me x squared. 10 squaring that gives me 100. First time, second, then double is that. So this part here is correct. This here is a subtraction sign. 36 and a squared are both squares. Okay, so this really is dots, but you have to manipulate this. So I'm going to rewrite 36a squared as 6a with my squaring on the outside. And now I see dots. Okay, if I cover this up with my fingers, I see something squared minus something squared. This is the difference of two squares. This just looks a little bit weirder because my a is x plus 10, it's quantity, and my b is 6a. Okay, but it's still the same thing. This is going to factor as a plus b times a minus b. Okay, it's two binomials. My a just happens to be x plus 10. So I'm going to fill that in for the a side. Okay, this is my a. So it's x plus 10 plus 6a and x plus 10 minus 6a. Now notice in this grouping I don't have any like terms. So I just leave it like this. Again, one more time. This was my a, this was my b. This is a squared minus b squared. It's always going to factor into two binomials. One's plus, one's minus. My a is the quantity x plus 10, and my b is 6a. So herein ends the this part of the factoring in Chapter P, Section 5. Again, if you have any questions, please post a comment. And keep in mind, there's nothing saying that you cannot pre-watch a video before coming to class and then using the class time to work on your assignments. Have a great day.